when we say trig manipulation, what we mean is using the definitions of these trig things. So here we've got sine x times cot x, and we can use the definition that cot x is cos x over sine x. So basically we want to use everything in terms of sine and cos, and we'll work out something else that it's equal to. So this is sine x over 1, because we're going to kind of write everything as fractions, so it's easier if we write that over 1, and then that's times cos x over sine x. So as we can see, these are going to cancel, and we're going to be left with cos x. So sine x times cot x is cos x. Also, just to revisit this quickly, if you weren't comfortable with cot x being cos x over sine x, just remember that cot x is 1 over tan x, which is 1 over sine x over cos x. And then to simplify that fraction, we multiply top and bottom by cos x. So then we end up with cos x over sine x. So with this one, we might let the 2x's worry us, but don't worry about it, exactly the same thing. So tan is sine 2x over cos 2x, and that's multiplied by cosec. If we look at the third letter, that's an s, so we know that this is 1 over sine 2x. Oh, and look at this, nice again, those cancel, and we're left with 1 over cos 2x, which is, third letter, sec 2x. Now we're slowly edging towards the concept of proof, which is a brilliant concept, and what we see here is that you're starting with cosec x takes sine x, and you can see at the bottom there that you want to end up with cos x cot x, so you want to prove that this is equal to the thing at the end. Right, so let's do what we were doing before. We'll write them as fractions. So we look at this s, that means it's 1 over sine x, take away, and then we're going to write that over 1 just to keep up the kind of fractions thing. And then so we can take out a factor of 1 over sine x, and that will, if we take out that, then we'll get a 1 there, and then this, since we've taken out 1 over sine x, this will give us sine squared x. And then next, we can see that this bit, we've seen this before in C2, so the 1 over sine x is going to stay the same, but this is going to now be cos squared x, and we should have written that over 1 as well, and then let's write cos squared x over 1. And so we can see that we end up with, well, if we kind of get this cos squared x, that's cos x times cos x over 1 times sine x. And I think the next line should drop out for you. Right, pause the video and have a go at doing this without looking, and then check your answer in a minute. So, hopefully you've had a good go at this. Now, like we were doing with that algebraic fractions, we want to write these over a common denominator. So we want to write this all over 1 take sine x times cos x. So to get the bottom of this to be 1 take sine x times cos x, we're going to have to multiply the top by cos x. So that's going to give us cos squared x. And then what did we multiply this by? Well, we were multiplying it by this. So then we've got plus 1 take sine x all squared. Can't really see my squared, but it is definitely there. Right, so you'll be neater than me and line your equals us up, but right, let's factorise this out. So we've got cos squared x plus 1, take 2 sine x, plus sine over, let's leave that like that, cos times 1 take, or cos x times 1 take sine x. Okay, and now we can see, oh yeah, nice thing from C2, so we've got cos squared x plus sine squared x, and that is going to give us 1, and then we've got another one there, so we've now got 2 minus 2 sine x over cos x times 1 take sine x, and I think you can probably see where this is going, 2 times, so we're factorising now, taking out a factor of 2, 1 minus sine x, and oh look, what's going to cancel? Those can cancel, and we'll be left with 2 sec x, which is what we want. Oh, and we can put a little box at the end because it's a proof, so we've proved it. Again, pause the video, have a go yourself, and then watch this after. So we're going to do 1 take cos x, that's going to stay the same, and then we're going to write sec x. We're going to use the definition, third letter rule, that's a c, so it's 1 minus 1 over cos x. Okay, so let's expand this, and we'll get 1 plus 1 over cos x minus cos x minus 1, and so those 1's are going to cancel, and we're going to be left with 1 over cos x minus cos x over 1. And if we take out 1 over cos x as a factor, just like we did with the last one, then we've got just 1 there. And then it will be minus cos squared x. And you can multiply this bit out if you're not sure how to get that. But yeah, okay. So then 1 minus cos squared x is sine squared x, as you know from C2. So we've got 1 over cos x times sine squared x. I'm running out of room, but we can write that as sine x times sine x, just like we did before, over 1 times cos x. And then so we'll have this bit being sine x, and then we'll have this bit being tan x, and that's what we want. So we have proved it, so we deserve to put a box at the end.